Hi, today we are going to talk about the four most common design patterns that you are going to use in a low-level design interview for solving the different problems. So the way a LLD interview works is you will be given a question, something like design a food ordering app. And then you will pick 4 or 5 most important functionalities which make up that system. Something like order the food or rate your order or search for restaurants which sell a particular food item using different filters. And then in the next step, what you are going to do is you will design your whole solution which satisfies these 3 4 features or functionalities that you just selected. And your interviewer is going to judge your design or your code on the basis of a few things. Is it easier to read? Is it easy to extend? How much code will be affected when we try to add a new functionality? Things like that. You see, in software engineering, most of the time we spend our we spend most of our time reading other people's code. We read other people code when we want to basically fix a bug or we want to add a new functionality. So it is critical, or I will say very important, that uh, your code is easy to read and then it is easy to extend. And this is where design patterns come in. So basically design patterns are used to split a large chunk of complex code. It can be a class or any module, basically into smaller classes, so that it is easy to read, understand, and most importantly it is easy to extend. And also most of the time if we make a change to that code, then the blast radius will be small. So typically blast radius is the number of places which gets changed, or the number of classes in which the you have to make the change when we are adding a new functionality or fixing a bug. So these are the benefits of using design patterns. And why I am talking about only four most common design patterns while not all 22 23 of them? You see, there are two ways to approach these things. Either you can go and just read about all the design patterns, but then you will be just scratching the surface. And even in the interview, you will not interviewer is not going to say you, okay, use this design pattern. They are going to give you a vague problem statement, and then you have to figure out which design pattern will be appropriate here, and then use that, and then defend your design choices. So you will be much better off using only knowing 4 or 5 design patterns in and out and using them, rather than trying to learn all the 23 design patterns. So this is my approach, which had helped me uh, with success in all these years, and I will recommend you do the same. Do the common ones, know them in and out. So let's see these design patterns and see what scenarios they can help us solve in the low level design interview. Our first pattern in the list is strategy design pattern. So we are going to use strategy pattern whenever we want to achieve the same result in multiple different ways. So let's take an example. Suppose you are asked to design a food ordering system, something like a Zomato or Uber Eats. So there the main functionality is to search list of restaurants. So which restaurants sell a particular food item. So what you see in your screen is a list of restaurants which sell a particular food item when you search for that food item. That list can be sorted in multiple different ways. It can be sorted by price, it can be sorted by rating. So what you need at the back end is different classes which implement different algorithms and return the results. Those classes, the input for them will be the same. It will be name of the food item, user's location, and some other parameters, and output will be exactly the same. It will be a list of restaurants, only the ordering will be different based on the algorithm. So this is a perfect use case for strategy design pattern. Another example, let's suppose we want to assign parking spots to vehicles in a parking lot. So again, there are different algorithms or different ways can be there for assigning the spots. You can assign the first come first serve, like return the first available parking spot which is suitable for the vehicle. Again, the different parking spots may have different pricing depending on whether it has a EV charger, or whether it is for the disabled, or some, or whether it is for the students. And you may have a completely different algorithm that returns a parking spot which is the cheapest. or if it is the costliest, something like that. Costliest means something that has a EV charger and it has a fast charger. So you see, again, we have different algorithms which do the same thing. Everyone returns a parking spot, but it returns a different parking spot based on the parameters that are given to it. Again, we have the, let's suppose you are asked to design a payment gateway. So there can be multiple different options: UPI, credit, debit card, net banking, and in each of these ways or options, the transaction fee is calculated differently. So again, we can have different strategy classes to achieve this, to calculate the transaction fee. So these are all examples of a strategy pattern. So let's see how the strategy pattern is implemented. Let's see a basic implementation of a strategy design pattern. We have a interface rating strategy, and this is the common interface which all the strategy classes should follow. So if you remember, all the strategy classes should have the same input and they should take the same, they should return the output in the same format. So everyone will return a list of restaurants, just that that list will be different for each different algorithm or each different class. Now this interface is implemented by all the different classes that we need. Let's suppose we are returning the all the restaurants which have the highest average rating. Okay, so this class can implement that. Now we may want to choose the restaurants where that particular food item has been rated the 5 stars most time. Okay, for example, biryani has been rated 5 star 41 times in a particular restaurant. That means that restaurants makes the best biryani in town. So I want restaurants like those. So we can use this class. So these are the two classes. And how we use these classes, pick one of these classes in the real time. We use one some sort of a factory or rating strategy assigner in this case. It has, now this is just one way to implement. We can put all the strategy classes in a map and assign them one or the other based on the context. So at runtime, we can assign one of the strategy classes, and there get restaurants method can be called to fetch the list of restaurants. So this is how a typical strategy pattern works. So what benefit has it provided us? Let's suppose tomorrow if we want to uh, have a completely different algorithm. So search restaurants, uh, basically return me a list of restaurants which sell this food item cheapest. For example, I want to order Maggie and tea. So I will, or basically I want to order Maggie. So I will search restaurants which uh, basically implement a class which returns list of restaurants which cheaply in sell food items in the order from lowest to highest. And there I will just add its uh, object in this map. And again, based on the context, that algorithm can be selected at runtime whenever it is asked. So this was about strategy pattern. Next pattern in our list is observer design pattern. So observer pattern is used whenever we have data, something like orders, parking spots, and then there are other classes which depend on that data. So whenever there is some change in this data, then updates need to be sent to these other classes. So this is where observer pattern is used. So in actual low-level design interviews, most of the time you will be using observer pattern along with strategy design pattern to send data to different strategy classes. We just saw strategy design pattern, so there are different strategy classes which are used to do the same thing, but in different ways. So let's take the example of a food ordering app. So you have the basically different classes which return a list of restaurants when we search for some food item. Now just we just saw that there can be multiple ways to do this. You can either return the list of restaurants based on their average rating. You can also return restaurants based on the number of 5 stars a particular food item has received. Now these search classes, they may need to maintain their own internal data structure, because it is very inefficient to calculate or build such a list at runtime for each uh, different request. So they may have their own inbuilt lists and they just update it whenever any new order gets rated, that is rate order method is called inside order manager, and update is sent to these classes, and they update their internal, it can be either list or a map or a combination of it, or some tree set, something like that. They update their internal data structure, and this is what the observer pattern is doing. It is gluing the class which is changing the data with the other classes which depend on that data. Another example can be of a parking lot. You can have multiple different parking strategies, and some of those parking strategies may have their own internal data structure, some sort of list or set of classes, or sorted set of classes, or some sort of combination of map and set. So those internal data structures need to be updated when the an spot has been booked using some other algorithm, so that the this algorithm can work correctly. So in these cases we use observer pattern. Let's see how we do it. Coming to the implementation of observer design pattern, the idea is that there will be a subject and a list of observers, and subject will maintain a list of observers, and whenever data change happens, it will call its method notify all, and it will call the update method on all observers. So every observer class will have a update method in it. It will implement this interface. Name of the interface or the method can be slightly different. It can be chosen by a, but it should be standard among all classes. So each class will have this update method. Now this subject will be something like our orders manager class, which have the rate order method. Whenever rate order is called, it will call notify all, and this subject will maintain a list of all observers. So notify all will just iterate through all the observers and call observer.update, which will one by one send update to each observers. Pretty simple. Add observer method is given, so now we can add observers at runtime. We do not need to update any code in the subject class or class implementing subject interface whenever a new observer comes. So tomorrow if a completely new observer comes, some sort of analytics class or some sort of notification class which sends a notification to an restaurant whenever any order is rated 1, 2 or 3, like low rating, that okay, you need to improve your services or culinary whatever experience. So there we will just implement the algorithm. It will have the update method, and at runtime it will call the add observer with its object and get added to the subject, and will start receiving updates. So you see both the classes, the subject where data is getting changed is loosely coupled with the observers, and we have the benefit of extension and readability. Next design pattern in our list is factory pattern. So this is basically a creational design pattern, and it is used to decouple the logic between how an object is created and how it is used. Now creating an object is simple in most languages. It's like a simple new statement. So why do you need a complete design pattern for that? So well, there, if it is only one object or two or three objects, then it is simple. But if there are many objects like 10, 20, 30, 40 objects, then it becomes cumbersome. And if some change happens in the creational logic, then we have to go and edit all in at all those 30, 40 places. So to avoid that, we use factory design pattern. So for example, you have the pieces in chess. So there are totally 32 pieces. There are two kings, one of white, one of black, two queens, one of white, one of black, uh, two knights each, eight pawns of black, eight pawns of white. So you see there are multiple different pieces, and there are total 32 pieces. So writing 30 overall logic for all these 32 pieces will be cumbersome. So what we do is we have a piece factory which have a creational logic, that is it creates a piece object using the color of the piece and type of the piece. So WK white king, WP white pawn, something like that. So this will make it easier. Another example can be some sort of a computer car race game. Now all of the cars have the same method, they race. They have some sort of accelerate method. They have some sort of a image method, thumbnail image method, which returns a 3D image which can move in the game. But implementation of all will be different. 3D image of a car, four-wheeler will be different from that of a scooter or from a truck, or even 3D image of two different cars like a Toyota and BMW will be different. So you see the methods will be same, but the implementation will be different. And in these cases, it is much better to use a factory design pattern to create them. so that at a later point of time, if we want to change it, we just have to change code inside that one factory class, and not everywhere that particular car has been initialized. So let's see how it is used. Let's use the car example for seeing how a factory design pattern is implemented. So there is a common interface which has the methods. It can be an interface or a superclass. It will have the methods which will be implemented by all cars. So for example, here we have taken two methods, get price and get acceleration time. Now every vehicle which wants to be a car will implement this interface. So Mercedes wants to be a car, it will have different values for price and acceleration time, or rather than Range Rover. So you see, both are different type of cars, both will have return different values. And whenever the ID is equal to Mercedes, we return a Mercedes. Whenever the ID is equal to Range Rover, we will return a Range Rover. But tomorrow, let's assume a new type of car comes, an electric car, something like a BMW i7. So what we do in that case? If we had not used a factory pattern and BMW still wanted to be a car, then we would have to go and change the implementation, or would have to add a parameter at every place a Mercedes or Range Rover is initialized. But we don't have to do it. What we do is we overload this get car method, have it take two parameters, string ID and is electric, and that method will return based on the ID parameter, it will return a BMW if it is an electric or non-electric BMW both. So you see, using factory pattern has uh, saved us from headaches of going and changing the creational logic everywhere whenever some sort of new parameter is added or changed. The final pattern in our list is singleton design pattern. And singleton pattern means whenever you need a single instance of a class, then you make it a singleton. So we'll see how that works. So basically we cast that instance inside the class object itself and return it every time we need the instance using getInstance method. So let's suppose for loggers, you need only one logger object to log in your whole project and all classes can use it. So yes, go ahead and make it a singleton. Only one database connection is required, so we can make that a singleton. Only one object of a thread pool is required and every one other class can use it, so we can make it a singleton. Another, for factory classes also, you need only one instance of those factory classes, like you need only one piece factory inside when you are designing a chess game, or you need only one car factory when you are designing a computer car game. So you see, there are lots of instances when a singleton pattern can be used, and that has made it like a potato. So it goes on with every vegetable, it goes on with every scenario, and that makes it the most used design pattern and also the most abused and overused design pattern. So I am here to tell you which are the places you should not use it. So precisely because using singleton pattern has its disadvantages. So precisely two conditions need to be satisfied whenever you are using a singleton design pattern. The first one is exactly one instance of class is required, and this everyone gets, and they tend to put it everywhere you need only one instance of the class. But the second one, that class will be accessed from more than one place in your code, especially in a multi-threaded environment. This most people ignore. So if your factory class like a piece factory is going to be used from only one place to initialize all the chess pieces, then there is no need to make it a singleton. So what option do we have? We can have a factory class which can return a piece factory object. It can initialize the piece factory object once and just return it whenever system starts, and return its variable whenever some class wants to use it. It will be much better. So why should we avoid making a class singleton? The first is singleton is not good for memory management. You create a class, you create a singleton class, you initialize it, and then it is going to stay there in the memory. It is not going anywhere, whether you use it or you don't use it. The second is, it is hard to unit test. You see, there is only one uh, state. You have only one object, and all the unit tests depend on it. So let's suppose one unit test changes the state of the internal state of that class. This can bring unexpected error in some other unit tests because it is difficult to mock. So again, the option is to use factories, or you can pass the object in constructor of the class where it is being used. So those options may be better. Let's see how it works. So how will we make a class singleton? What will you do is, will first it make its constructor private, so it cannot be accessed from anywhere. Then what we do is, we have a static variable of its own. So this instance variable is of the type singleton and it is static, and we have a static method get instance, and we use this method to get the only instance for this class. Now again, this class is doing two things. The first one, it will have the methods that is required by other classes that will actually be used by other classes. The second thing what this class is doing is, it is polishing the instance, that it is making sure that only one instance of this class gets created. So again, this also violates the single responsibility principle. So this is sort of another disadvantage of making a class singleton. But for now, let's see the implementation. In the get instance method, you first of all check whether the instance is null. If it is not null, then this block will be skipped and directly the instance will be returned. So we have only one instance. Now, what if it is null? Then we come to the synchronized block. So we are assuming that we are in a multi-threaded environment. When we come to the synchronized block, we lock on singleton.class, that is the static form of it, and check again. This is the double check that the singleton that the instance is null. If it is not null, if it is null, then a new singleton object is created and assigned to the instance reference variable. So why this double check? Let's suppose two threads entered inside this if block. The first one created a singleton object, and now it is referring to the singleton object through this instance reference variable. If the second thread entered after it and this instance equal to null check was not there, then what would happen is, this instance variable will get overwritten by a new object. So now this instance will point out to different object, and the previous thread would actually still be pointing to the older singleton object. So now we have two, or you can say if there are multiple threads, then multiple singleton objects created in our system, which we do not want. We want to prevent that. So the double check is required. This is how you make a class singleton. How will you use it? It's simple. Singleton.getInstance. This is a static method, so we do not need to instantiate the class. Simply call getInstance, and that's how you use it. Now this is just one of the ways of making a class singleton. You can do it simply in a much simpler way. It says if it's a single threaded environment, you can do it at a startup, but again, you do not want to load too many classes at the program startup. So this is one of the ways that I decided to show it to you. You can try out other ways, see it from the internet. So these are the 4 patterns that you need to master if you want to do well or clear low level design interviews. You should use strategy design pattern when you want to implement the same thing using in multiple different ways. So return the same list, not same list of restaurants, return a list of restaurants, but ordered using different strategies or different algorithms. You should use observer pattern basically when you want to send updates from subject to a list of observers. So whenever any order gets rated, you want to send that update to all the search classes, search restaurant classes, which depend on the rating, so that they can update their internal data structures. You use factory pattern when you want to decouple the creational logic of the object from its usage. So the class which is using the object should not know about its creational logic. So it is advantageous when you have tons of objects, 30, 40, 50 objects, so that when later you want to change some parameter or update some parameter, then you do not have to go at all those 30, 40 places and change the code, even if it's a single line. Because then you will also have to retest all that code. You have to change code only in a single factory class, and that would be enough. Finally, if you want only one instance of a class, some sort of a logger, then you use singleton, and you should avoid overusing it. So that was all about the common design patterns. If you want to read a few more design patterns, then the state pattern is important, and it can be used to solve some very difficult low-level design problems, some sort like elevator design pattern, which I consider one of the difficult problems in LLD interviews. Now, if you are preparing for LLD interviews, then I will recommend you to try the CodeZym 7-day preparation plan, codezym.com/roadmap. It has all the videos and all the theory and practice questions on a daily basis. The most important and the most common questions or material is during the first few days. So it will help you to prepare efficiently for your low-level design interviews. So give it a try. It's totally worth it. And I wish you the best of luck for your interviews. Uh, Keep trying and best of luck. Bye. Thanks for watching.